Hello everybody and welcome to another live training session on Unity. My name is Mike Geig and welcome. It's been a while since I've done one of these, so I'm actually quite excited to get back into it and start doing these again. Now, for those of you watching this recorded, you've actually already missed out on quite a fun discussion on top-down versus isometric games in the chat, but I'm sure we can still talk about some fairly useful things. Real quick, just so everyone's aware, I have recently upgraded to Windows 8.1. Wasn't necessarily my choice, but my computer wouldn't start, so I said, to heck with it, let's do this. So my settings have all been redone on my streaming, so hopefully this works. This is the first time I'm streaming with my new settings, and hopefully we don't have any issues. I am also streaming 1080p. Normally I stream 720. So again, fingers crossed, hopefully this works. If not, I might have to stop the stream, downscale back to 720 and come back. Hopefully we don't have to do that, but just be prepared in case we have any particular issues. All right, so today's topic is top-down 2D games. And a lot of the conversation going on in the chat already is, what exactly does that mean? Some people are asking about games like Zelda, right? Or The Legend of Zelda, the original Nintendo, where it's kind of top-down, but it's kind of not. It's kind of at an angle, right? And so, to my knowledge, games like that are basically called isometric. They're not truly isometric, but they're just called isometric. They're top-down, but still things are kind of on their sides. We're not really doing that. We're doing true top-down today, but the only difference between true top-down and Zelda's kind of isometric style, or the original StarCraft's isometric style, is just the art. And whether you draw it top-down or whether you draw it at a 45-degree angle, that's literally the only difference. So, and that's kind of what we're going to be looking at. I shouldn't have mentioned Windows, because now everyone is is talking about Windows in chat. Okay, so like I said, we're going to be talking about 2D games, top-down, and to get started, I know a lot of people had asked me for a drawing, so I did make a drawing. I kind of want to talk about how top-down games actually kind of work in Unity. And so I had this little demonstration here, and you could see on the left, we've got kind of our top-down game where we have our action shooty guy kind of shooting these ghosts and whatnot. And that's how a top-down game kind of looks, right? Just running around and everything's flat, but really what's happening, if you look on the right, is what's really happening. And this is basically that the whole world is kind of flipped on its side. All right, so in this way, our guy is actually kind of suspended halfway down the screen. Gravity is still along the y-axis, right? Which means what we're expecting gravity to be is along the z-axis, right? It's not really the case. It's always along the y-axis in Unity. Maybe someday in the future there'll be a setting that we can choose which axis gravity is on, but for now, gravity is always on the y. So what that means is with top-down games, we cannot use Unity's built-in gravity. If we need gravity, if we want the ability to jump or anything like that, we have to implement it ourselves, right? We're not going to do any of that stuff today, but I just wanted you to be aware the biggest difficulty with top-down games is not really making them. It's the customized algorithms you have to use, because we're no longer dealing with y is the up and down and x is the left and right. Well, we are still dealing with x is the left and right, but z is in the in and out, right? With top-down games, the whole world kind of gets flipped. So the algorithms we normally use, we can't use anymore. And we have to use kind of changed algorithms to utilize these new axes, all right? So that is what my picture here is meant to represent. And I kind of got carried away with all the stuff. So it's actually a rather busy picture. But so, okay. Real quick, before we get started, the reason I'm doing this is because during Global Game Jam back in January, I made a game called Masks, and I had a lot of fun with it, and I thought, hey, this would make a fun live session. So I kind of want to show you what I mean when I talk about top-down games, all right? And so we have this game map. Pardon the little intro. I always do this little intro to the games I make. But this is a game that's for the Global Game Jam 2014. You can actually go and download this. The source and everything is from the Global Game Jam site. And basically, it's this kind of top-down 2D Hotline Miami style, where the player just sort of follows the mouse, all right? And in this particular game, I'm a big fan of bloodshed and violence in games, a big proponent of violence in games, so that's kind of what I have here, is a lot of violence in games, and we just, move on to the next levels and so on and so forth, but it's this whole top-down style, right? That's the kind of top-down style I want to talk about today. And so what we really need to do is, and I'll go ahead and move this now. What we really need to do is we really need to do something along those lines, the top down. And what I discovered when I did this for Global Game Jam is that the algorithms were all different. And I thought, hey, maybe some other people would like to know these since I spent the time to figure them out myself. Now, I will be using some assets today, and you can all get the assets for following along later from this website, and I'll bring this back over here. So japan.unity3d.com /developer/document/tutorial/2D-shooting-game. Okay, you can click English. This is the Japanese site. Click English and go to the very end. You can download the assets. They're all in there. So these are the assets that I'll be using for today, and you can follow along. And so I'll be using the ship's assets, but I did make my own like laser sword, and I just made that in Photoshop with a gradient. So you can just feel free to make any sprite you really want for the laser sword. Doesn't really matter. Okay. So that's where you can get those, and you can find out that. And it actually occurs to me right now that I have forgotten to put my laser sword inside my folder with everything else. So let me just handle that real quick here. Sorry about the delay. This will just take a moment as I locate my laser sword, and I put it inside Unity, and there we go. No, there we go. Now I got my laser sword. Cool. Okay, so we have kind of a blank slate here. I've got my screen, and I've got my hierarchy and my inspector, and this is just sort of a layout I just sort of threw together. So you're used to me normally working in the default layout. I've sort of changed some things around, so this is kind of how I'm working with it now. So what I want to do first is I am going to go ahead and put in our player. Okay, we're just going to start with the player. I always like to start with the player. I feel that's a really good place to start. So if you've downloaded, or as you're watching this recorded, obviously you guys don't have this now, but I have this spaceship PNG sprite. And I'm kind of going to go through the workflow again of 2D. I know I've covered this before, but it's always good to just reiterate. So I have this selected, and in Inspector I can see the sprite type. So I'm going to go here to multiple to tell it that there's multiple sprites in here. I also want to specify the pixels to units. On this particular one is 50, just so they're a little bit bigger. And I'm going to go into my sprite editor, and I'm going to go ahead and hopefully OBS captures this. It looks like it is. Okay. And I'm just going to change my slicing type to grid, and I'm going to change my grid sizes to 48 by 48. And then hit apply. That'll give me my spaceships. Okay. And I can just expand this now, and I'm just going to grab my first spaceship and drag and drop, and there we go. We have a spaceship. Okay, so kind of for this game, just so you know, the previous game, that mask game you saw, you're kind of this dude with a sword walking around hacking people up, and you know that's all well and good. But I had to decided to be a little less violent, so now we're a spaceship with laser swords. Just because I thought, hey, what if a spaceship instead of shooting guns just had a sword? You know, why not? Maybe I watched too much Pacific Rim. I don't know. And so we're going to fly around in our spaceship and slash things up with our laser sword. So we have our player now, and what I want to do is I want to move my player with physics. Now, I had already talked about how we can't really use built-in gravity and things like that, which is true, but the rest of the physics still works the same, right? So don't think that just because we're making a top-down game, we can't use physics. We just can't use gravity, and we can't rely on the axes the same way as we normally do. So we're going to look at some custom ways of doing this. All right, and so what I'm going to do is with my spaceship here, I am, oh, that's weird, that won't let me resize. Oh, there we go. With my spaceship, which I'm actually just going to rename player, what I want to do is I'm going to go ahead and add a rigid body to it. So physics 2D, rigid body 2D, since it's a 2D object. And I want to take my gravity scale, I want to make it 0. I do not want gravity. Remember, gravity is our enemy in top-down games. And I'm also going to want to change my linear drag to 5. You'll see in a second here, we'll play around with it. I'll show you why I set the linear drag to 5. Because otherwise, the spaceship is just going to fly all over the place and it's going to be all slippery and whatnot. So we want it to have some drag. Okay. And then finally, what I want to do is I'm going to add a collider to this. I don't need this yet, but this is for the future. So again, physics 2D, box collider 2D. And I'm just going to go ahead and bring that in a little bit. And bring it in a little bit. Something like right about there. All right. You could get more accurate results with a polygon collider, However, polygon colliders are less efficient than box colliders, and this game isn't going to be super precise, so that's really good enough. Real quick here, I'm going to read through chat, just make sure I'm not missing anything. One of the questions, can't you change the gravity axis? No. Unless you can, and I just don't know about it, but I'm pretty sure you can't. If I'm wrong, just let me know. But I'm pretty sure you can't. Let's see here. Okay. And you can use gravity in a 2D game, you just can't use the built-in gravity. You can have jumping in a 2D game, just your jumping is towards the camera. Anyway, I mean, that's just, I'm just being technical, nitpicky, whatnot. Okay, and so, great. So we have our guy here, he's got a rigidbody 2D on him, I added a linear drag, and I put a collider on him. And so now I need a script to just sort of handle his mobility. So I'm going to create a folder, I'll call it scripts. And I will add a script to it, which we'll just call player mobility. And I will just click and drag onto the player. And so this is our first bit of math with our top-down 2D games, okay, is this script here. And you're going to see that we're going to kind of do things a little bit differently. And let me zoom in here. I always forget to zoom in. This time I remembered, so I feel pretty good about that. So here's my little disclaimer. I am not a math guy. I do not math well. I like math. I'm not particularly good at it, okay, as far as, you know, higher orders of math. So there may be a better way to do what I'm about to do. If that's the case, please let me know. Just email me, put it in comments, whatever, all right? I am simply doing the math that I made work. There might even be Unity built-in functions that do this. I'm not, this is my disclaimer, I'm not claiming to be some expert on math or to be knowledgeable in all things Unity math. So if there's a better way, please let us know. But this works for me, so that's good enough. So what I'm going to do is I'm going to have a public float speed, because we got to have speed, right? And then I'm going to do all my updates inside fixedupdate because I'm using physics, right? I'm going to push my ship with forces. And so I'm going to do void fixedupdate. That's not right. There we go. I always apologize for my mechanical keyboard, so I apologize for my mechanical keyboard. And so now what we want to do is we want to find the mouse position. Now, if we're doing like a Zelda game where you can move up, down, left, or right, this becomes super easy. Just rotate the ship, right? And like by 90 degrees along the z-axis and then move it, right? Life gets real simple. However, I really liked Hotline Miami. I thought that game was amazing, and so that's the kind of control I want to emulate. Hotline Miami, you follow the mouse, and so that's what we're going to do. So what we need to do is we need to take the mouse's position, we need to find it in world space, and then we need to rotate to it, and then we kind of need to limit our rotation so that we're only rotating along the z-axis. And I'll show you what happens if we don't do that correctly. And so what I want to do is I'm just going to create var mouse position as a variable here equals camera.main.screen to world point. Screen to world point. And then what do I want to turn into a world point? It's going to be inputs.mouse position. So that's just saying, hey, where's my mouse? Tell me where that is in screen or in world space, and that's what I get. Okay. Now I need to figure out my quaternion rotation here. Sorry, I'm just reading chat here. Some people are talking about math. Hello. Gravity questions. Okay. var basically is me being lazy. I could just write float, but var just makes this whatever it needs to be. So that's why I write var. It's kind of something that was stolen from JavaScript. So yeah, works for me. I'm actually, sorry, Zeth Jack, I'm not using JavaScript, I'm using C#. var is something that's in C# now that was stolen from JavaScript, so yeah. But that's what var means. Var means I don't want to specify what this is, I just want to basically allow it to figure out what type it is. Yeah. Which does come from JavaScript. var isn't, well, it might come from somewhere besides JavaScript, but JavaScript is the most widely used use of var. Okay, so anyway, I'm getting off topic now. So let's talk. We're going to create a quaternion, which we will call rot for rotation. And that will equal quaternion, quaternion.lookRotation. So lookRotation is basically going to be like, hey, look at this, right? And this is going to be the quaternion to do that. And what do we want to look at? We want to look at our ship's transform.position minus, all right, minus the mouse position. Okay, just like that. So we're going to say, hey, look at transform.position minus mouse position. Okay, and then what do I want to be my forward axis? It's going to be vector3 dot forward. Okay, and I had to put this on 2 lines because, well, you know what? I can do, get out of here. There we go. Now I don't necessarily have to put it on 2 lines. I'm zoomed in so much that, oops, that it's hard to fit it all on a single line. I don't know why that disappears. Oh, come back. Okay. Anyway, so it's just on 2 lines. Not a big deal. All right. For whatever reason, MonoDevelop is not letting me put this back on the other line. I don't particularly care. Whatever. So this gives us our quaternion rotation that's going to enable us to look at what we want to look at. And then finally, I'm going to say transform.rotation equals rot. So this sets the rotation of our ship to be the rotation required to look at our mouse. Okay? So I'm going to go ahead and leave this the way it is right now. But I'm going to warn you that this is not completely correct. Okay? I want to show you the results of this. So I'm going to come back into Unity here, and I'm just going to go ahead and hit play. And what do we get? You would think, hey, this works fine, right? The ship is looking at the mouse. But I want you to pay attention to what happens as I move. See how the ship skews up and down? All right, that's due to it rotating on a bunch of axes. It's not just rotating on Z, it's also rotating on Y. Okay, and so that's no good. So what we need to do is we need to limit that. So that's why we have our next line here. And our next line is basically going to be in the process of saying, hey, I only want the Z rotation, I don't want the X or the Y rotation. So I'm going to say transform.Euler-Angles. Transform.Euler-Angles equals new vector3 and 0, 0. That means no rotation on X, no rotation on Y. We only want the rotation on Z, and we'll pass back into that, oops, lowercase t transform.Euler-Angles.Z. That just strips away the X and Y rotation. Okay? One more step we need to do is going to be rigidbody 2D dot angular velocity equals 0. This step is a little bug I noticed. It's not really a bug, it's just physics, right? That when we do this, every once in a while our ship will just kind of rotate and slide, right? And it won't stop. And the reason is just due to calculation precision, so by doing this, we prevent that from happening. You can remove that if you like that little slide, but I don't, so I removed it. So there you go. Okay, so that is going to give us the proper rotation without any of that distortion. And so the next thing I want to do is I want to say, hey, if the player is pushing the vertical axes, so the up-down arrow or the WS keys, I want to move. And this is why the rotation is important, because now all I need to do is move it forward, whichever way forward is. Now again, normally when we move something forward, okay, we're moving it along the z-axis, right? In 3D games, forward is the z-axis. However, right, we're making a top-down game. So forward is actually either the x-axis or, in this case, is the y-axis. Again, that's kind of where the difficulty comes from, is we need to manage which axis we're doing this stuff on. So you can't just move it forward, quote-unquote. You have to move it along the y-axis. And so what I'm going to say is I'm going to say float input. I could also do var input, just for those of you not quite sure what var does. I could do var input or float input. That will equal input.getAxis. And I'm checking the vertical axis. And then I'm going to do rigidbody 2D dot add force. And what am I adding? I'm adding GameObject dot transform dot up, because I want to move along the y-axis, times speed times input, which will basically mean if I'm hitting an input button, it will equal 1 or -1, in which it'll move. If I'm not, it'll be 0, and this whole thing won't move. All right, cool. So here's our script that's going to give us both our looking at the mouse, and this part is our movement. I'm going to come back here into Unity, come to the player, I'm going to set my speed to 40, and I'll run this. And now I can fly around, always chasing the mouse. Now, let's talk about these values. if I were to say, set my speed to say 20 and reduce my linear drag to 2.5, so half in both regards, I'm going to still move the same speed. The difference is I'm going to slide a lot more. Alright? Because my drag is less. And it'll take me longer to stop. See, once I let go of the key, it glides a good distance. Alright? Inversely, I could set this to 7.5, and I could set my speed to 60. And it'll stop much shorter. So that's kind of how you can control using the physics, the 2D physics, exactly how much inertia you want. By increasing my speed and increasing my drag, I have effectively less inertia, and I'll be more grippy on the ground. I found that 5 with a speed of 40 suited my taste, but you can kind of change it however you want. So one of the questions is, what is fixed update? Fixed update is basically where we do most of our physics, right? Because unlike regular update, which can happen whenever and however fast our computer can go, fixed update happens at a set time interval always. So notice I don't have to multiply things by time.delta time because I'm in fixed update, and fixed update always moves at the same rate. I don't need to do that time.delta time. Can the rotation be restrained to the z-axis in some other way? Or is that the only way? Like I said before, this is just the way I did it. If you can come up with another way, great. I did it this way. So, absolutely. If you find another way, please let me know. And then other people talking about fixed update. Let's see. Oh, same questions. Can I explain vectors a bit? No, not in this video. We have a vectors video on the Unity site. Please feel free to check that out. But it's really not kind of what we do here. To set the FPS for fixed update, we can just go into physics, or we can call fixed time step. But if you come into project settings, physics, 2D, you can change all that, or just set it through code. Okay, so that is our player flying around. I want to keep moving because I've got a bunch of other stuff I want to show you. So that's our player flying around there, and we get a pretty neat effect there. So let's go ahead and animate this. Now, you saw in my previous live lesson when I did the 2D character controller how we can make the animation by going into the animation window and stuff like that, right? I want to show you another way. So what I'm going to do is I'm going to come into sprites here, and I'm just going to grab all 4 of these spaceship sprites. Just highlight all 4 of them, and I'm just going to click and drag all 4 of them onto the player and let go. And this window is going to pop up and say, hey, create a new animation. What do you want to call it? Let's go player animation. Whatever, just some arbitrary name. And I'll hit save. So what happens is it creates an animation for me. It creates an animator for me. It links the animation to the animator, alright? And sets basically everything up for me. I'm going to uncheck apply root motion, by the way. We don't want that. Not in 2D games. Not yet, anyway. In Unity 5, we can have root motion in 2D, which is pretty cool. But anyway, so all that stuff is done for me just by clicking and dragging. Let's hit play. And now my ship is animated. Pretty neat, right? I didn't have to set up animations. I just grabbed a series of sprites, clicked and dragged, saved it as an animation, done. So that's pretty cool. I certainly like that. That makes creating this stuff pretty quick. Okay. Sorry, we got a lot of chat today, so let me just read through this real quick. Let's see. Quick question, what does sprite refer to? Sprite is effectively a 2D graphic. Realistically, a sprite is something that's meant to move, as in the old definition, but basically a sprite is an image that's put on a quad. It's flat, and so we call them sprites. Okay, they're not really models per se. I mean, they are on a quad, but that's just really what they are. They're sprites. Okay. Let's see. Pretty cool. Okay. Welcome back says, wouldn't you just rotate the camera by 90 degrees and move it on top to keep gravity working? Yeah. Well, not really. You won't be able to use the 2D scene view. 2D scene view snaps it along the z-axis, so we wouldn't be able to work with that, and so things would get much more difficult. I'm sure we can rig it, but just basically saying we don't generally need gravity in top-down 2D games. Let's see here. Okay. Another question, why do you use sprite sheets? Sprite sheets are great because they reduce the number of draw calls because they're all technically one texture, and so to draw all of them is only a single draw call. So sprite sheets are great for efficiency, so I highly recommend you use them every chance you get. Now, let's go ahead and create our bad guys. Okay, so we just, and actually, let me create a folder here called prefabs. I always like to save this stuff, these prefabs, drop it in there. Because then we can just build levels real quick and easy by just clicking and dragging stuff. I love using prefabs. They make level development after your initial tests super, super simple. Like in that mask game I just showed you, I can create a new level in like 20 seconds. I just create a scene and just click and drag all these prefabs, and the behaviors all just automatically work. It's quite fantastic. Okay. So, now, let's go ahead and create our enemies. Oh, someone else had a question. Is fixed update more reliable to use than multiplying by time.delta time? No, they're completely different. Update with time.delta time is great for everything. Fixed update is great for when we're doing physics. So if you're not doing physics, use update. If you are doing physics, use fixed update. There you go. That's just your rule of thumb. That's just kind of how we do it. Mike, your tutorials are awesome. Thank you. Okay. So now we have the player saved as a prefab. Let's go ahead and create our enemy. Now you saw before how I clicked and dragged a sprite into the scene, and then I added stuff to it, and then I added the animations. So check this out. We're going to go ahead and create the enemies an enemy real quick. I'm going to come back into sprites, and this time I'm going to click and drag 4 of these images. So 1, 2, 3, 4, I've highlighted them. I'm just going to click and drag them into the scene. It's going to say, hey, create new animation, which I will say enemy animation. And save. And look what I've got. Now I have an enemy with an animation, right? So I didn't even have to drag the initial one in there. I can just click and drag them all, drop them, and I have an animated sprite just sort of idling away doing its own thing. So that's pretty cool, right? It's now named Spaceship 4, which I'm going to rename to Enemy. Cool. So it's really that easy, right? I'm just going to move it, click and drag, right? All right. And so, someone says, it takes too long to use sprite sheets. It's worth it. Make your artists always do sprite sheets. Absolutely worth it. Have to do it. Okay. I noticed a little blip lag on the video here, so hopefully that doesn't happen again. Oh, are we lagging? I don't know if Twitch is lagging or if my video is lagging. So hopefully it is. If you guys can hear me, just shout out that it's still working or whatever. I don't know if it's Twitch or what it is. Okay. So now we have our enemy, all right? So let's go ahead and set the enemy up. So I'm going to uncheck apply root motion because we do not want that. And then I'm going to add component, physics 2D, rigidbody 2D, which again, I'm going to set up linear drag to 5, and I'm going to set gravity to 0. And then I'm going to go ahead and add a box collider. So physics 2D, box collider, and I'm going to go ahead and bring in my box collider so that it more adequately matches my spaceship. Cool. We also have an interesting problem. Notice my player ship. My player ship is aligned pointing to the positive Y direction, while my enemy ship is aligned pointing to the negative Y direction. That's going to mess our calculations up a little bit. All right? And we'll see it. What's effectively going to happen is our enemy's back end is going to point at the player, and I'll show you a real simple way to fix that. So, okay, so now we have our enemy here. So let's go ahead and just set up a quick script for the enemy. So create C# script, call it enemy script, and click and drag. Maybe. Click and drag. There we go. And we'll go ahead and open it up. So in this case, we no longer are looking for the mouse. Now we just need to point at the player. Okay? And so what we need to do is we need to have a few things. First thing we're going to need is a public float speed, okay, obviously, and then we're going to need a public transform player, so the ships know what they're supposed to look at, all right, and then again, since we're doing physics, we're going to use fixed update. Rule of thumb, if I'm using physics, I'm using fixed update. So here's where the math gets fun, and again, I'm just going to reiterate it again. I'm not a math guy. I do not math professionally, so this is the math I got to work. If you come up with a better way, please share it with me. I'm always down for learning. So don't feel like this is absolutely the best way to do it. This is just the way that I was able to do it. And then drab web in chat here totally ruined the surprise. So Darn you. Okay, so I'm going to say float z because I want to figure out my z-axis rotation. I'm not rotating along x and I'm not rotating along y. Only rotating along z. And what I'm going to do is I'm going to say mathf dot a tan 2, which is my arc tangent 2, okay? And I'm going to say for my arc tangent, I want to find player dot transform dot position dot y, okay, minus transform dot position dot y, okay, comma, and then player dot transform, no, not player prefs, player dot, stop it, player dot transform dot position dot x minus, and then I guess I'll drop down to the next line here because I'm running out of space, transform dot, no, not uppercase transform, come on mono, you can do this, transform dot position dot x, okay, and then and our parentheses, and I'm going to multiply the whole thing by, I don't know why I didn't drop it down there, multiply the whole thing by mathf dot rads 2 degrees, radians 2 degrees, minus 90. Okay, and then I'm going to hit semicolon and it's going to do this whole readjustment. So basically, I'm going to say it again. Float z, the z-axis rotation, is our arc tangent 2 of the player transforms positions y minus the transform position y, comma, player transform position x minus transform position x, times our radians 2 degrees minus 90. I know that's a lot of weird math. Trust me, it works. That's why I said if you can come up with a better way, please feel free. But this seems to do the job just fine, and this is what I've been using for a while, and I've never had any problems with it, so there's got to be a simpler way. I just don't know what it is. So once we have that, okay, what we are going to do is we're going to say transform dot Euler angles equals new vector 3, and I'm going to say 0, 0, and then z. Remember, z right here. We don't obviously want any rotation along x and y. And then finally, I'm going to say rigidbody 2D dot add force. Now this one isn't dependent upon the player pressing any keys. The ships are just going to follow you, like little zombie ships. Game object dot transform dot up. Okay, and then I'm going to say times speed. Okay, and so that's just going to move us along our positive y-axis. All right, and so now I'm going to come back here and I'm going to hit play. And the problem we're going to see, oh, besides it lagging, you can do it. Someone says, you're just reading what you wrote and not explaining it. Would you really like me to get into explaining arctangent math? I don't think we have time for that. I hit play, but I forgot. Under the enemy, I need to specify the player. So we'll just drop the player in there. And I need to give it a speed. I'm going to give it a speed of, say, 5. And I'll hit play. And so you can see this isn't quite what I want, is it? It's following me backwards. All right? So what I really need to do is I need to get it to turn to face me. So as DrabWeb had already specified, what we can do is just scale it to the -1 on the y-axis, which flips it upside down, and then now it's following me great. So there we go. Yeah, before that ship was trying to back that thing up, and so now we need to get it to flip around. In the words of Missy Misdemeanor Elliott, bring that thing down, flip it, and reverse it. Okay, so now, we have our player, our enemy, chasing our player around the screen, facing the wrong way. That's exactly what we want. And like I said, I'm going to apologize. I'm not explaining the math, because I don't know what arctangent 2 does. I know that specifically works, right? We could also flip the imported sprites, absolutely. So Oblivion also had a point. We could just flip the sprite art assets, and that would work just fine. However, the sprite sheet that I got, that's the way they're facing. So without going back to Photoshop and flipping it and cutting the sheet up and all that nonsense, I can just flip it here inside, flip it inside Unity with a -1 on the Y scale. Okay. Oh man, I got to get going. We're running late. We still need to blow things up. All right. So at this point, our enemy ship is following the player around, and that's all well and good. So let's go ahead and come to our prefabs folder. Let's make our enemy a prefab. Let's zoom out a bit and let's just bring a bunch of them in. Enemies everywhere. And let's just grab every one of those and specify that the player is who they want to follow. Okay, so now they'll all follow the player, and if they run into me, they'll just start pushing me. Right, zombie ships. Or like amoebas in the body or something like that. If you're making a biological game, right? Why not germs or whatever. Okay, and so now what we want to do is we want to add our attack animation. This is really the thing I wanted to show you the most, right? Because this is, we're going to use actually mechanism animation layers, which I've never shown you guys before. So hopefully you don't know it, or I guess hopefully you do know it, but if you don't, you're going to learn something new. And we're going to talk about how we can get a swinging weapon and actually blow things up with it, right? Which is all pretty cool. So now we have all these enemies, but for right now, I'm just going to go ahead and disable them. Goodbye, enemies. Because I just want to be able to play around with my ship for a bit without enemies coming and going. So what I want to do is I want to go ahead and create on my player a sword. So I'm going to come into sprites and I'm going to grab my laser sword. I just made this with Photoshop. It's just a gradient in Photoshop. So you know, feel free to use any image you want. It doesn't particularly matter. And so I have this sword, and what I want to do is I want to nest it onto my player. So sword is a child of player, and on player I'm just going to hit apply, which is basically saving it to my prefab. Okay. And so now what I want to do is I am going to basically make it so I can swing this sword around. So with the sword selected, I do need to have on it a box collider. So physics 2D, box collider, which I'm going to set to a trigger. Okay, so I don't want to actually push things with the sword. I want to have it call up some code when it hits something. Okay, and then I'm going to come back to my player. And in my animator, I can see right here that we have our animation state, which is just the ship kind of idling. Okay, what I want to do is I want to create a new animation on a new layer. So I have my base layer right here, which is where my ship just idles. Right. As a matter of fact, if I click my ship and then run it, you can see it idling, right, as the rockets are going there. So what I'm going to do is I'm going to create a new layer, and I'm going to call this layer attack. This is my attack layer, and I'm going to give it a weight of 1. I'm going to ensure that my blending says override. I don't really want to get into the rest of this stuff. You can always look the documentation up for this, all right? But this is kind of what I want here, okay? So I have this layer, and I can just go ahead and minimize it now. It exists. There's nothing on it. And I'm going to create a parameter, which is going to be a trigger, which I'm going to call attack. And finally, I'm going to create a blank state, create a state, right-click, create state empty, which I'm going to name idle. Ooh, which I'm going to name idle, I said. There we go. It's default. Oh, come on. I set idle. There we go. And it doesn't do anything. Because by default, I don't want this sword flying around the place. I just want it to idle, where it's not doing anything. Okay? And I'm going to click on my laser sword, and I'm going to turn it off. Deselect. So by default, the sword is not enabled. Okay? It's just invisible. It's invisible, no collisions or anything like that. Cool. So now this particular work with our animator is done. We have our idle state on our attacking layer, and nothing else is happening. So let's make this animation. Okay? I'm going to go ahead and go to animation, and what I want to do is I currently have player animation. That's just the idling of the ship. I'm going to create a new clip, which I'm going to call attack anim. You can name it whatever you want. Attack anim. And I'm going to set my sample speed to 36. The higher this number, the faster the animation. The lower this number, the slower animation. I tested this before. I liked 36. Your mileage may vary. All right? And so now what I'm going to do is I'm going to add a bunch of properties to this. So the first property that I want is I'm going to select, and the nice thing about this is even though this is the ship, when I hit add curve, I can see all children elements. So player has a child called laser, and here's laser, right? Isn't that awesome? Check that out. And so I'm going to go into laser, and the first part of my animation isn't animation at all. I'm going to just hit plus here so I can determine whether it's active or not. So the very first frame of my animation activates my sword. Obviously, I need to make my sword active. And the last frame of my animation deactivates my sword. Cool? So my sword starts off not active. When the animation starts, my sword activates, plays the animation, then deactivates. Cool? That way we're not running around with a dangerous weapon, because that sounds dangerous and we could accidentally poke someone's eye out. So, now, I'm going to come back to my first frame here, and I'm also going to add curve, laser, transform, position, and add curve, laser, transform, rotation. Cool. So I can actually expand this and specify these values, but that's a bit tedious. So instead, right, with a frame selected, you'll see that these numbers turn red. What that means is it's actively recording what I'm doing. So if I change it here, it'll change here. Okay? So for my first position, all right, I'm going to say negative 0.75, 0.8, 0, with a rotation of 45 degrees. That's where my sword starts. Okay? Then I'm going to say, and actually, you know what, let's move this. So, right about there. And then what I'm going to do is I'm going to come and say 1, 2, 3, 1, 2, 3. Let's go right here. Sure. I mean, it's not an exact science. We can go one more if we really want. I just want to make sure I have a middle point. Yeah, I have a middle point. All right, so on this last frame of animation, I'm going to go ahead and just select here, and I'm going to say positive 0.75 with a rotation of negative 45. So you can see kind of what's happening. Now this isn't quite right yet, but we're getting there. And then one frame later, or actually we'll do 2 frames later, is where I'm going to put my deactivation. So the reason I'm putting it 2 frames later is so we can actually see it. So it spends 3 frames in this mode, then it swings, and then spends 3 frames before it deactivates. Okay, and then I'm going to go to my middle point here, and I'll create a keyframe by just double clicking. And in my middle point, I'm just going to say that my position is 0 and 1. Ooh, what happened? I did something wrong. I'm messing with the player and not the sword. And the sword is what I want to be messing with. There we go. 0, 1 with no rotation. Sometimes you spend a little bit of time playing around with this, but you get what you want. 1's not quite enough. Let's go a little bit further. It's just a matter of just playing around. So that now I can grab the scrubber and go, hey, that's a pretty good arc. Right? And I don't, oh, and then I don't want these extra frames here. So, goodbye. Oop. Goodbye to you and goodbye to you. There we go. Now we got a good, sorry, I'm just sort of talking to myself as I do this here. I'm not actually even reading chat. So what I have here, so this is attached to the ship. The ship just has the laser. Since it's a child object, I can manipulate it. All right? And so now if I play this, that's what my sword swing looks like. All right? Just like that. Okay. And so the next thing I want to do is I'm going to click my attack animation. I'm going to make sure it does not loop. All right? I don't want it to loop. And I'll come into the animator, and with my attack layer highlighted, I'm just going to click and drag my attack animation. We are almost there. So now what I want to say is from any state, I want to transition to my attack animation. Right? I just right-clicked any state, hit make transition, and attached it to attack animation. If you're curious about mechanim stuff, we have tons of mechanim videos, so I'm not going to spend a ton of time explaining mechanim. So I'm just going to click this transition and just say, hey, whenever attack becomes true, go from any state to attack animation. Furthermore, I want my transition time to be nothing. So, bloop, no transition time. So it transitions immediately. Then, I want to go from attack animation back to idle. Right? Just right-click, make transition, attach it to idle. When my exit time equals 1. Exit time equals 1 means it played 100% of its animation. All right? I need to zoom out here. And again, I don't want there to be a transition. So I want it to happen instantaneously. So there we go. So now what it'll do is as soon as attack becomes true, it'll play the attack animation. As soon as that animation is done, it's going to come back to idle. All right. So long story short, if I lost you there, This video will be recorded. You can come back and watch. But basically, I just created a rudimentary animation, right, that I then linked up here on the attack layer. What's nice is that since my base layer and my attack layer doesn't have anything with the same name, right? Except attack animation got added down here, but that's just a placeholder, so it's not really that important. It's up here that's it matters. I don't have to specify what layer in my mechanism script. I can just say, hey, set the trigger, and then mechanism's going to handle it for me, right? So the whole thing actually gets really, really simple. So now all I need to do is I need to set in my player script that, hey, when I click the button, swing the sword, okay? And so I'll come back here to my player script, and I need to first off find my animator. So I'll create a variable called animator anim. I'll use the start method to get that component. Anim equals get component animator. There we go. And then in update, void update, I'm just going to say if the player clicks the mouse, if input dot get mouse button down 0, which is my left mouse button. So if they hit the left mouse button, I'm going to say anim dot set trigger attack. Again, if any of that mechanism stuff lost you, we've got like 13 videos on mechanism that explains all of this stuff. So don't freak out. We got videos for you. We'll show you how to do it. But basically, I'm just saying, hey, when I click the mouse, set the trigger attack. Once this becomes true, we go from any state to player attack animation back to idle. And that's effectively what's happening. So if I click play and I click my button, I've got a space laser sword. It becomes active and deactive. All right? Now, I mean, that's all well and good, but it doesn't do anything yet, right? So we need another script. And this one's going to be our sword script. Remember how we added the collider to our sword? And we set it as a trigger? Well, this is the script that determines what exactly that does. So I'll just click and drag onto my laser. By the way, I haven't applied my player in a while, so just make sure I got my prefab updated. Double click this script. Sorry, I'm going fast. I'm trying not to run out of time. And inside here, I'm just going to say on, void on trigger enter 2D, which takes in a collider 2D other. Now we're going to say is, hey, whatever you collided with, blow that sucker up. Really, we should have some checks in there to make sure we're not blowing up things that we need, but destroy other.gameObject. Boom. That's simple enough. Let's re-enable our enemies, and let's unleash upon them some space naval justice. I guess it's naval. Is it naval in the space? I don't know. They name them after ships. Boom. Boom. I don't know. Is it because they call them like space armadas? I don't know. It's all science fiction. I'm going to call them a navy, whatever, because it's science fiction. It doesn't exist, so that's what I'm going to call it. So we have now a laser sword that blows up bad guys. All right. If we wanted it instantaneous, we could have like a polygon collider, which we enabled, which would make it like instantaneous, like flashing weapons, you know, like if you wanted like samurais where they swing the sword really fast, we could just take a polygon collider and just enable the whole arc at once and everything inside of it dies. But this is just a slower, kind of more methodical way of doing it. Either one really works. Okay, I am going to take this moment to say that you really shouldn't be instantiating and destroying all these objects on the fly like I'm doing. You really want to object pool them for efficiency. I'm just going to throw that disclaimer out there. I have a video on object pooling on the Unity site, so feel free to check that out. I'm doing it here because it's simple and it's easy, and it's a rather small project. Now, for those of you who watch a lot of my videos, you know that no video would truly be complete without an explosion. So I like the fact that we can destroy these enemy ships, but I feel that it's really lacking in explosions. So let's go ahead and add an explosion when we blow up these ships. Okay? So I have here my sprites, and you'll notice I have this explosion sprite sheet. So you can see that I've kind of been planning to blow things up this whole time. And so now what I want to do is I am going to, first off, I need to slice this up. So I'm going to come in here, I'm going to say this is a multi-sprite, and I'm going to go to sprite editor, and I will slice it based on grid, and I will say that it is 80 by 80, slice, apply. All right. There we go. Someone said colliders don't collide with other colliders nested on the same parent. Yes, they do. if I wasn't careful and my laser sword actually clipped the collider of my ship, I would kill myself, right? Luckily, I built the laser sword so it arcs over the collider and doesn't actually hit. So one of the things that my sword really should do is say, hey, if I'm hitting the player, don't kill the player, right? I'm not doing any checks, but really you should. But yes, like a lot of things that beginners do is they fire a bullet from inside a gun, and the first thing the bullet does is collide with the inside of the gun and kills the player. So I always wonder, hey, why not? When I fire a bullet, I die, and I don't know why. It's because the bullet's colliding with the player, and it's killing it. And so you always need to do checks to make sure the bullet can't hit the thing that starts it, or start the bullet in front of it. In this case, the sword cannot hit the player because it starts in front of the player and never goes over the collider. So yeah, be sure to just keep that in mind. Okay, and so I have my sprites, my explosions all sliced up. So again, I'm just going to click and copy or grab all of those into my scene. Boom. It's going to ask me what I want to name it. I'm going to name it explosion animation, which I get this. Okay, which I'll just name explosion. And back to my prefabs it goes. Bloop. And now I can just delete it. Goodbye. So now I have this animated explosion, which again I'm going to turn root motion off on. And so now, here we have. So all I really need to do now is say, hey sword, when you kill something, spawn an explosion. Furthermore, I have to say, hey explosion, when you're done exploding, die. And so I'm going to create C# script, which I'm going to name explosion script. And I'll basically put that on my explosion by clicking my explosion prefab, add component, scripts, explosion script. Okay. Now let's open this up and let's hook the two up. So my sword script, I'm going to create a public game object explosion. And when I kill something, I'm going to say instantiate explosion, where I'm going to instantiate it at other.transform.position with a rotation of quaternion.identity. So that will create an explosion every time I slash something. In my explosion script, I basically need to create a function, void die. And what die does is it destroys itself, lowercase g. And in my start method, invoke die after 1 second. This is so that after the explosion is done, right, we don't have all these game objects that were explosions just lying around. Now again, we really should be using object pooling where these just go back into a pool, but I did not use object pooling for this, so instead we're just going to destroy it, and that's all well and good. So I will come back here, and on my laser sword, I need to specify what my explosion is. Boop, just there, and I'll hit play. So now, I am a spaceship samurai. Wait, I forgot something very important. There we go. Now I'm a spaceship samurai. Before it was airplane samurai. Now I'm in deep space, slashing up enemies with my laser sword. Okay, so this is a bit ridiculous, but yeah. So someone here says, Mike, call the die method from the animation instead. You would kind of be right. The problem, Pixel Stealth, is that I have noted a bug in 2D animation specifically, that when the animation calls an event that destroys the object the animation is on, it freezes up Unity. I don't know why. I've submitted the bug report. Hopefully it'll get fixed. And yeah, but basically I couldn't. It wouldn't work. It just either wouldn't call or it'd freeze up Unity. I don't know why. It works fine on 3D, but just with the 2D stuff that I've made, it just doesn't work. So that's why I'm doing this. Can't you use destroy game object comma 1F? Yes, you can also do that. The reason I invoke instead of just calling destroy, because you can do destroy 1F like that to specify time. The reason I do this, it's really just a personal preference, but so that I can cancel invoke if I need to. I'm not saying there's ever any reason to cancel the invocation. We do want this to die after a second pretty much every time, but I just invoke so if I wanted to, I could cancel invoke so it wouldn't die. I don't know. That's just, it's habit. It's you know, there's a lot of different ways we can do everything. This is just one of those ways. Mike, great video. Thank you. Question, are these scripts going to be available after the video? No, I don't have any way of getting them to you. Just watch the video and just type as I type. I don't have a method of sharing with you. Sorry. The problem is I could host on my own personal like Dropbox or whatever, but you know, Unity doesn't own that, so that just doesn't really work out. So sorry. I mean, just follow along slowly, type them out. It's good. It's good practice. You should be typing. I should not be giving you everything. You need to exercise your fingers, make them strong so you can crush bricks. Let's see here. Let's see. Great video. Question or the other way. Could you instead spawn the sword in front of the ship when it attacks instead of making the sword an animation? Yeah, I mean, you could. The animation, so you can get this nice swooping arc to it. You could just spawn it. I don't know why you'd choose that method, but it's personal preference, right? Yeah. But anyway, so now we have our Space Samurai sword that flies around and slashes. So this was a top-down 2D kind of tutorial, but really we didn't focus a lot on the top-down stuff. Really just the turning and facing is the most difficult part of that, because we're not using the Z-axis, we're using the Y. And the rest of it was just a little bit about animation and mechanism. One more thing, I am over time, but one more thing I do want to point out real quick. A lot of people are talking about like isometric view and what's on top and things like that. And realistically, like games like Zelda, things don't actually overlap, even though you're kind of seeing the side of Link, right? It's still top down. The art just draws it on the side. But if that becomes a problem, sorting layers is how we solve that. So let's say in this instance, I want my sword to appear on top of everything else, right? Everything in here has a sprite renderer, right? Sprite renderer, and the sorting layer is always default 0, okay? What I could do, just to specify, is I can take my laser and just say, hey, I want it to be 1 on the default layer. And so it will always appear on top of everything else on the default layer. Or I could open up my layers, go to Edit Layers, and under Sorting Layers, I've got Default. I can add a new one. I can just call this one on top of default, right? And since it's higher than default, I can make it also lower than default if I wanted to, but that wouldn't make a lot of sense. Since it's higher than default, everything that's on that layer, like my sword now, which I can put that back to 0, will always appear on top of everything else, right? Everything else is on default, and this is on the on top of default layer, right? And I could create another one under sorting layers, one more that's just called behind default, or we could call it ground if it was our ground, whatever, and just put it behind, right? So for those of you who are always curious, how do we get things to be sure which things are drawn on top of other things? We can use our sorting layers. And the nice thing is we can change those sorting layers on the fly with code. So it's really not super difficult, right? So making certain things appear on top of other things is really not all that hard. And it's actually one of the more important parts of 2D game programming to make things look right. Okay, so let me read through chat here real quick, because a lot of people have questions. Can you explain scenes and how to change levels in code? Well, that doesn't really apply. You can maybe ask me that question later, but scenes are basically just like levels, collections of assets. You can change them in code by writing code that can be accessed and modified level elements. It's kind of a generic question. All right, let's see. Let's see here. Oh, yep, that's how you change scenes. Don't destroy. Okay, so I see these. Most of the things inside here are for other stuff. Can we use sorting layers for GUI? Yeah, we can. We can do GUI a bunch of different things. I generally have used GUI to have a separate camera, which I keep off to the side, and all my GUI elements are on that. 4.6 is coming out soon. I can't give you an exact date, but soon. I just don't know the exact date, or else I would tell you. At this point, I don't really care. But soon, and the GUI implementation of that is fantastic. It's wonderful. Please check out videos on that. I wish I had a date for you, but I don't. So soon. UGUI will have all that stuff. Yeah. All right. How much future career opportunity is there in Unity game development? A lot. I don't know. A bunch. How would you go about making an attack combo? Is there anything like... Yeah, attack combos are just basically animations chained together and things like that. I mean, where we have... I mean, right now you could see I kind of from any state to attack anim to idle, and we can have attack anim to other attacks based on key inputs and buffering. I mean, it gets a little bit more complicated, but we can do that all through mechanism. Ooh! here's something that I forgot to show you. This is why we did this on 2 layers. If anyone ever wondered why I just didn't put the attack animation on my base layer, because I could have just, my idle is my ship and then transition to my attack. The reason is because I can have 2 animations playing at the same time, right? 2 layers, watch. Notice how I swing my sword, but my engines keep going. Get out of here. So I swing my sword, but my engines don't stop animating, which means I'm playing 2 animations at the same time. I could have 3 animations at the same time with 3 layers and so on and so forth. That's why I put them on separate layers. I forgot to mention that. So if you're sitting there thinking, why not just put them on the same? You could, but that's the difference. All right, so that our animations don't interrupt each other, because they're completely separate. One is the sword and the other one's the ship. So even though they're static images, it doesn't really matter. So, okay. All right, so at this point, I'm going to go ahead and wrap up the video. I will hang out and chat for a little while longer to answer any questions you guys have. So if you have questions that I did not answer, I apologize. I wasn't exactly watching chat very carefully this time. You know, I will stick around and answer those. Thank you all for watching. Sorry it's been like a month and a half since I've done one of these. I'd like to get back on a regular schedule, but it is hard with me traveling so much. Hopefully you all enjoyed this video, and it will be uploaded here as soon as I can, and I look forward to seeing you all next time I do one of these. Nothing is scheduled yet. I believe Adam has another live training scheduled. I do not. I need to get one scheduled. I just haven't yet. So stand by and wait for that. And otherwise, thank you all very much. Have a fantastic day.